Hi guys. So last time we learned how to plot points in polar coordinates. So just a quick reminder, so far we've been learning like two systems of coordinates already. The first one is the one that we most familiar with. Let me just change the marker, oh no, the pen. Okay, let me use black in here. So the first one is what I refer to xy plane, xy coordinate, or the rectangular coordinate. Let me just put the word rect in here for rectangular coordinate. Is when we have like two axes in here. The vertical axis, we're going to call it the y-axis, and the other one is x-axis. And we also have the origin in here, and the point for it, the coordinate for it would be 0, 0. This is the one that we usually like work with, right? Like that is the one that we know. And the one that we just learned from 10.1, we refer it to the polar coordinate. In this polar coordinate system in here, we start out by having like a pole in here. And then we also have like a polar axis in here. So the coordinate of the pole, it is 0, theta, where theta can be any angle that you want it to be. So theta in here could be like 45 degrees, 1 degrees, or like pi over 2 radian, pi over 6 radian, whatever thing you want, okay? And the polar axis is always just like a part right here. Like if you want, you can extend it to the outer side, but then we don't have any outer axis in this one, in the polar system, okay? And I told you guys you can treat it like the four quadrant invisibly. So just imagine that you're gonna have like four quadrants in here, in here, in here, and in here. So for example, on the second page or on the third page of 10.1 in my lecture link, I show you guys how to like there's always like two ways to write to represent like a point polar coordinate, right? So for example, let me do like a random point here, for example. So I want to represent this point here. So the fastest way, like the direct way, is when we have like the positive radius in here and theta to be acute, where theta is this angle and it has to go like counterclockwise to be positive angle. If it go clockwise, then it's gonna be negative, okay? And this is r, okay? And I told you guys the other way to represent this point here is when you extend like the outer side of the radius in here, and when you use the outer side of the radius, automatically the radius would be negative, so it goes like this. And after that, you have to ask yourself how much rotations are like, what is the angle measurement of the angle starting from the polar axis and ends in the red arrow in here, or like the other side of the radius. So with that saying, let me draw out the arrow. So it's gonna look like this. And I told you guys like just by eyeball it out, as you can see my like red. Okay, let me erase this mark a little bit in here because it looks so ugly. And I told you guys because this arc in here is a little bit exceed 180, or like half the circle, right? Or half the semicircle, sorry. So the angle in here, it would be pi plus theta, okay? And the outer case, when it is not like yet a semicircle, then we're gonna have something like pi minus theta, okay? Let me redraw my plus in here because it looks too nasty in here. Okay, there we go. Now it looks even weirder. Okay, let me just put pi plus theta. Perfect. And that would be our angle in here, pi plus theta in here. And they are the same point, okay? So as I told you like a minute ago, there are always two ways to represent a point in polar coordinates. There's a direct way and there's an indirect way. So my direct way, let me put it in green. And then the indirect way is when we use the outer side of the radius. I'm gonna put it in red, okay? And from there, we also learn how to convert a point from polar coordinate to rectangular coordinate and vice versa. And the last topic that we learned from 10.1 is how to convert or how to transform an equation from polar coordinate to rectangular coordinate and vice versa, okay? So some tips in here, some formulas that we have to like memorize in here. Let me like separate the page in here first. Is first, make sure you remember that the radius r equals to the square root of x squared plus y squared. And if you don't remember it, make sure you draw like a triangle or like a unit circle, whatever you want to start with. like a circle in here first, and then we in the XY system, and then from there we have like a right triangle, say in the first quadrant, and this would be our little theta in here. Opposite to it, we have little y because it's a vertical distance, and adjacent to theta, we have little x because it's the horizontal distance. And this point here, we're gonna call it x comma y. Okay, and this one here's the origin 0, 0, or just like O if you want for shortcut. And based on the picture in here, since we're on a right triangle, so if we go for tangent of theta, we will get opposite divided by adjacent, which says that y divided by x, right? And then also for the other way around, let me change the color again. So let me put it in, I don't know, like pink in here maybe. Okay, so also remember that back in the day we have x equal to cosine of theta and y equals to y equal to psi of theta. But remember, since we out of the unit circle, so the radius doesn't have to be 1 anymore, so we have to attach little r in here. And with the same logic, y equals to little r times psi of theta. Okay, and let me just put back little o in here. Okay, so that's the case in there, so make sure you remember these formulas in here. Don't forget them because they're really powerful. And as for the last point, when we try to transform equations from polar coordinate to rectangle coordinate, I told you guys there's like 2 tricks in there. The first one is that you multiply by r. So let me put like times r by 2 sides of the equation. Sometimes that helps. The second way is to square up both sides. Okay, and I told you guys sometimes you don't have to use like all of these like 2 methods in there. Like it's just based on my experience. These method will come helpful somehow in the problem depending on the problem, but chances are you don't have to use it like all the time for all problems that you encounter with. Okay, so just go with the flow in there. If you see the fraction, think of cross multiplication. If you see like sine and cosine standing alone by itself, use the first trick to multiply by r by both sides of the equation. And if you see some square in there, make sure you square up both sides. And after that, just go with the algebra. Make sure you don't forget all the algebra techniques such as factoring, the X method, diamond method, box method, and so on, whatever like name you want to call it for factoring method. Just go with the flow, and eventually by practice, you're going to get used to it, okay? And let's talk about today's lesson. Okay, so today we'll talk about complex plane, which is similar to our XY plane. So a complex plane, it has a little bit of XY plane or rectangular coordinates, and it's also have a little bit favor of the polar coordinates also. That's why I introduced it like last. This will be the last section of the trig class, right, of our trig class. All right, so let me use like red in here. So we all know that back in XY coordinate or like the rectangular coordinates, we have 2 axes. The standing one in here, the vertical one, we call it Y. And then, let me change the color again. And then the horizontal one in here, we call it the X axis. Okay, so we're going to advance it a little bit and take it to the further stuff. In the complex plane, we're going to have the same deal in here, but instead of having X and Y axis in here, we're going to call X to be our real axis. So let me just put the equal sign here for X to be real axis, and Y, it would be our imaginary axis. Okay, and in here, a point, instead of having the coordinate of like X and Y, still going to have like the coordinate of X and Y as the old day, but then we will represent it in another way, right? Because this one in here is the form for a rectangular coordinate. In complex plane, we will have is represented by Z. Okay, so this one in here is in complex plane. Let me just put it like Okay, so in a complex plane, a point would be represented by X plus Y. I in here, as you can guess, is shortcut for imaginary. That's why it's a little I in there. And again, X in here is the real part, Y in here being the imaginary number or like the imaginary like part in there. Okay, and then speaking about this picture in here, I want to clarify, I want to show you guys again that the 2 axes in here, we have to change the name of it, so it's not going to be Y axis and X axis anymore. We're going to call it real axis and imaginary axis, okay? And for every point here, we can always draw like a line here, and the distance from 0 to z, the point z. Back in the day, we used the word radius, okay? But in the complex plane, we're gonna use the word modulus or magnitude of the point z, okay? And we represent the magnitude by taking the absolute value of it. Like the symbol is like similar, but absolute value is like taking the absolute value of a number, right? And here we have the magnitude. Absolute value cannot ever be like negative. That's why like the idea of being magnitude is like it's understood in a similar way. So technically the magnitude here is like how big you are, how big your like you are, how big your point is away from the origin, or like from the pole, or like the big O in here, whatever you want to call it. The distance in here by the Pythagorean formula, it equals to like x squared plus y squared. It's just a similar idea of saying that we have c squared equals to a squared plus b squared in here. A in here would be x, and b in here would be y, and c in here would be little z in here instead of r. So last time I just remind you guys like a second ago that r squared equals to x squared plus y squared, right? In here we're gonna have the same deal. Z squared equals to x squared plus y squared. And if you want to find z by itself, we're gonna take the square of it, and then the z in here, for it to be like positive, we come up with a name, we call it magnitude. That's why we have the little kind of like absolute value symbol in there, okay? So this one is a big formula that I want you guys to like memorize or like remember, okay? And another key idea in here is about a conjugate of it. So we talked about conjugate when we proved the identities, when we try to establish like new identities back in like 8.3 or 8.4 already. But the idea of conjugate is that technically you only just change the middle sign, okay? For example, if I give you something like, I don't know, like -1 plus 2i in here, or even to make it more interesting, let me just put negative 2i. So minus 2i, okay? So the conjugate of this one, let me give you guys two options in here, and then you guys will think for yourself in a minute which option is the right conjugate of -1 minus 2i, okay? The first one, I'm going to do 1 plus 2i, and the second option we're going to have is -1 plus 2i, okay? I'm going to give you like 5 seconds to think for yourself which one in here is the right conjugate of -1 minus 2i. Ready? Okay, so I hope that everyone agrees with me on this one, that the conjugate, the right conjugate for -1 minus 2i is this one. Ooh, that's a bad color. Let me backtrack. Okay, let me continue using, I guess, red in here. Okay, so this one in here is the right conjugate of -1 minus 2i. Why do I say so? Why is this one not the conjugate? Okay, so the idea of conjugate is that you allow only to change like just one side, right? And the side that we change in here is the middle side. You cannot touch on any other sides in here. That's why the first option in here, I'm going to exit out because we're changing like two sides in here. We're changing the side of 1 and we're changing the side of 2i also, which is not right. We are only allowed to change one side, which is the middle side in here. So we turn like a negative in here and to a positive in here, and that's it. We're not allowed to touch on this negative in here. Okay, so if it's negative at the beginning from the first part, it will stay negative, like as for the first part on the conjugate. Okay, so make sure you don't get confused over this problem in here. As for like symbol in here, let's start with the z number, a complex number having the form in x plus iy, and the conjugate of it, again, we're changing the middle side, so it turns out to be x minus iy. And the symbol for the conjugate is z bar. We're gonna do a bar on top of it. So say if I want to find like the conjugate of -1 minus 2i, I can have like a little bar on top of this thing in here for the symbol of like conjugate, and I can equal it to 1 plus 2i, okay? So just a heads up in here, a little bar on top of it is meant for conjugate, okay? It's meant for conjugate. And if you take a further step and you multiply z with z bar, so z in here equals to x plus iy, and then z bar equals to x minus iy in here, you multiply, you FOIL it, like first inner, outer, and then last, something like that, and you combine the like terms, and then you end up having x squared plus y squared, right? And if you notice, x squared plus y squared, we saw it already in here. So that means that z times z bar in here can be representing by the inside of the square in here, right? And putting everything together, we're gonna end up having the magnitude of z, which is absolute value of z, or like I'm gonna call it magnitude of z because it sounds more like right, like more appropriate to the meaning of it. So the magnitude of z in here is equal to the square root of the product of z times z bar, or the conjugate of z. Okay, so again, the takeaway from this page is that I want you guys to remember, I don't know like what's a good color to underline, so let me just box it for you guys in I guess purple. Okay, so the two formulas that I want you guys to remember is first this formula in here where we have the magnitude of z equal to the square root of x squared plus y squared. And the second formula I want you guys to remember is the magnitude of z also equals to the square of z times z bar. Okay? And then let's move on to the first topic of the day, converting a complex number from rectangular form to polar form. Okay, so once we have a complex number, we know how to plot it in our xy coordinate already, but how can we plot it in polar coordinate, right? Like that's would be our next question. So in 10.1, if you guys remember, in each of the example, I always ask you guys to draw a point in both coordinates, right? I asked you to draw it in the xy coordinate, and I also asked you guys to draw it in the polar coordinate, just to confirm whether your pictures make sense. If the points matches each other like in the two coordinates, then the answer will be right. But chances are like that's not always the case, right? Like sometimes in the last example, I remember this one picture, the angle is meant to be on question 2, but then for some reason we had it ended up on question 4, right? That's why we have to make some like adjustment to that, and then we change it to obtain our correct answer. So watch out for it, okay? Like if you don't know what I'm saying right now, you might want to rewatch the lecture video on 10.1, and if you have any questions for that, let me know, okay? Like email me, please. So now what we're going to do is that first we will have to convert our complex number to polar form, and then after that we can base off on the radius r and the angle theta of the point that we plot in the picture to get our polar system. Okay, so just a heads up in here, recall that we have x equals to r cosine and y equals to r sine. So then if we solve for like cosine of theta in here, cosine of theta equals to x divided by r. And let me put this one in green. And because y equals to r times psi theta, so if we solve for psi theta, we will have psi theta equals to y divided by r. Okay? So r in here, it has to be like strictly positive because this is the radius. So it has to be positive in here, and the color sucks, so let me change it to red. R in here, it has to be positive. At least it has to be 0, but it cannot be negative, okay? And the angle in here, it has to be within 360, so we cannot have something like 400 degrees or like 3 pi or something like that, okay? And again, any complex number would be represented by in the form of z equals to x plus y, yi, where x is a real part and y being the imaginary part. In polar form in here, we have to plug in x for r cosine and y in for our psi theta in here. So putting everything together and factoring out the y part, we have this formula. So to represent a complex number in polar form, we will have z equal to r times the quantity of cosine theta plus I psi theta, okay? This one actually is a really big formula. It's a big, like, it's a huge, like, discovery. It means a lot, and it's, like, has a lot of, like, application to it when you come to calculus or, like, something further than that, or, like, even in differential equation if you go for, like, engineering major. So, anyways, back to this one. To convert a complex number to rectangular form, First of all, we have to identify x and y so that we can compute the radius. And after that, we're going to plot it out because we already know like the xy, like we know the location of it. So we're going to plot it out in the complex plane. After that, we have to compute cosine value and then sine value in here to get the angle. Because here's the thing, like some of you guys might ask me like, isn't it just enough if we get the cosine value of theta and then we do cosine inverse and then we get the angle? The answer to that is no. Because for every time you get like a cosine value, when you do the inverse function, you're gonna get two values, right? Like if you remember it from like 8 point, I don't remember the number anymore, but like if you guys remember from probably like 7.2 or 7.3, say in the circle in here, for example, x and y coordinate, where the x-axis will be represented by psi and the other one is like cosine value. This one is my cosine. Okay, so for any like cosine value, for example, like a negative cosine value in here, we will always have like two angles to match it out for that cosine value, right? And for like any sine value that we have, for example, if I give you something like this, you will always have like two angles that match out to have like the same sine value in there, right? So knowing just one value in here, that doesn't give you like the angle that you want. But if you know both sine value and cosine value, that will help you determine your quadrant and will help you determine your angle. That's why we need two values, not just one, but two values, okay? And after that, we're gonna get the angle theta in here. And at the end, now that we have r and we have like theta in here, we're gonna put everything together and then we have the coordinate, the formula of z, okay? In fact, you don't even have to solve for theta sometimes because as long as you know cosine and sine, you can plug it in here and in here and ready, right? So let's talk about the first example that I had in here for you guys. So let's say if the problem gives us something like z equals to -1 plus I, right? So the first part in here, because we know that z equals to x plus y I, so -1 in here is our x part, and then I in here, or like 1 in here, would be our y part. If you want to make it clear, I would recommend writing the 1 in front of I so that we know that the -1 is x and then the y in here would be 1. So remember, y is not I, okay? The I is always there as an attachment to the imaginary part. I is not your x or your y. It's just like an attachment of letter, okay? So with that saying, now the point goes like -1 and 1, right? So that's why I have a point here, -1 and 1, represent this number in here. Okay, so right at that, because I know x and y value already, so I'm gonna get my r. So I plug in, I use the first step in here to get the formula for computing r, and r equals to x squared plus y squared. That's why I had like -1 squared in here plus 1 squared equals to like 2, and then I take the square of it at the end. So second step is that I plotted, and then I plotted already. And then the third step in here, I'm gonna go get my cosine value and sine value in here. So then what I'm gonna do is I'm gonna use the formula that I had attached in here for you guys. Cosine of theta equals to x divided by r, and sine of theta equals to y divided by r. X is -1 by like given, and y equals to 1 by given also. R equals to square root of 2 because we just like got it from the first step in here. We plug it in, we get the value of cosine and sine already, and then now you have to ask yourself, what value or like what angle gives you cosine value of -square root of 2 over 2 and sine value of square root of 2 over 2? And before you do that, watch out for the size in here. Like my trick in here is that I always like look for the sine first to know what quadrant my angle lies in, and from there I get to decide the measure of the angle, okay? So let me draw like a unit circle in here first, and then xy axis or like cosine and sine axis in there. Because my cosine is negative and my sine is positive in here, that means the x part is negative and the y part is positive, right? So that means I'm in quadrant 3, so it has to be here somewhere. But what angle is it? So if you guys recall it from the table, from the chart I made you guys remember, the only family that has square root of 2 over 2 for cosine and psi is the 45 family, right? So from here, I'm gonna like have a mark in here. So this is my like angle of the 45 family in here. And if you guys do the math, like the first quadrant from here to here is already 90 degrees, right? Another 45 degrees in here, so we're gonna do 90 plus 45, and that will be 135 degrees, right? And if you go ahead and convert it back to like a radian system in here, we will end up having 3 pi over 4, okay? And after that, now we just have to piece everything together and write it as the formula in here. So we have z equals to r, and then cosine of theta plus I sine of theta. R in here is square root of 2, we just found it, and then we just put in theta in here, and then we're done with the thing, okay? So you don't want to write your answer as square root of 2, and then times 1 over square root of 2, and then plus, negative 1 over square root of 2, and then I, and then square root of 2 over 2. Please don't give me something like this, okay? I want you guys to find me the theta. That's why I want you guys to put it in this form, even though I know the value of cosine theta and sine theta. All I need in here is the angle, okay? And why do I need the angle? Because I needed to plot for the point in the polar coordinate, right? So we start off with the pole in here, and after that we're gonna have like a polar axis in there. And because we know that theta equals to 135 degrees, so it's had to be like somewhere in here. And then we extend it to like square root of 2 unit away from the pole, and then we have the point here. Okay, so just to confirm in here, this one is in quadrant 2 in like complex plane, and then also in our polar coordinates is also in quadrant 2. So then this one is the right answer. Okay, that's why it's really important to like piece everything together and connect the graphs at the end, because visual like pictures, it helps you a lot. It helps you to make sense of the answer a lot in here. And as for your like try part, I want you guys to try this example in here, and then I give you like 2 coordinates in here. This one I want you guys to think of it in the complex plane, and the other one is for polar coordinates. Okay, so give it a try and let me know if that works. Okay, so next topic in here, let's see what we have in here. Okay, so every complex number represents a point in the complex plane, right? We know how to plot points in a rectangular form already, but how can we plot points in polar form? Well, we can convert a point from rectangular form and plot it, right? So first off, for example, let's say if the problem gives us something like this, right? Which is like what we just had a minute ago. How can we know how to plot it, right? So we know that this is r already, and then on the inside we know theta already. So the point of it will look like square root of 2 comma 3 pi over 4 if you want to convert it into radian system in polar coordinate. So this one is in like polar coordinate, it's not in rectangular coordinate yet. So how can we do that? How can we turn how can we convert a point from polar coordinates back to rectangular coordinates, right? So number 2 is actually the easy part compared to number 1 in here, because all you have to do is you have to evaluate the cosine value and the sine value of theta in here. And if you guys remember, so first of all you have to, okay, so I didn't give you guys a unit circle, and I'm expecting you guys to know how to compute the cosine and sine value, or like any trig values of any angle using reference angle. So I still hope that you guys remember the reference angle. So first of all, let's draw like the XY system in here, and then where's 135, right? Like it should be in quadrant 2 because it's bigger than 9 degrees, so it should be somewhere in here. Okay, so let me just make like an angle in here. So this one is my 135 degrees. So what is the reference angle of 135 degrees, right? I told you guys the reference angle is always about the x-axis. So the reference angle in here, let me change the color to blue. It would be 45 degrees in here, and why you get it, you're gonna do like 180 minus 135, and then we get 45, okay? And just a heads up in here, because 135 is on the second quadrant, so the x and the y part of it, the x part will be negative and the y part will be positive. That means that the cosine value will be negative and the sine value would be positive, okay? Just a heads up. And what is the cosine value and sine value of 135, right? Like, we don't know that, but we do know the cosine and sine value of 45 by the chart I made. You guys remember? I still hope you guys remember that chart. So in here, let me put it in blue again. By the chart I made, you guys remember, cosine of 45 degrees, it equals to square root of 2 divided by 2. And psi of 45 degrees, it equals to square root of 2 divided by 2 again. So let me fix my 2 because it looks so weird. 2 in here. Okay, and then since it's negative for the cosine part and it's positive for the psi part, let me put it in here. Actually, let me change the color to emphasize that the negative and the positive in here is coming from the green part, like the quadrant part, not coming from the reference angle. It doesn't let me write. Oh, eraser, that's why. Okay, there we go. And green. Okay. So the point in here, or like the coordinate in here, would be negative square root of 2 divided by 2, and the psi value in here would be square root of 2 divided by 2. That's how I end up getting the two numbers in here and in here, okay? And make sure you don't forget the little I in here to tell you that the y part is for the imaginary part, okay? After that, what you're going to do is that you multiply, you distribute the square root of 2 in. So the square root of 2 will cancel like partly with the 2 on the bottom, and we end up having negative 1 plus I, okay? Simple enough, right? So I would expect you guys to draw the first one from the polar coordinate and the second one from the complex plane, okay? So from polar coordinate, it's pretty easy. It's pretty straightforward, as you guys already like have the point there. As for the complex plane in here, because you guys having like the point here, so you guys just like match out to the correct like coordinate and plot them out, okay? For your part in here, I'm mixing out a parentheses in here. Sorry for that. And just a heads up in here, what you need to do is that you have to find a cosine value and a sine value of 315, right? So the first step in here, and in the test and in the exam, you guys have to show me how you guys get these values too. Okay, don't use a unit circle, because if you like use a unit circle and then you got the answer like right off the bat by looking at a unit circle, I will know, and I'm gonna mark you guys off for showing no work for that. To obtain the cosine value and sine value in here, again, you have to draw out your reference angle in here. So first off, you have to determine where's 315 lies in, and if I'm not wrong, it should be in question 4. And after that, you're going to get the reference angle of 315. And just a heads up, in question 4, the x part is positive, but the y part is negative. Okay, so make sure your cosine value is positive and your sine value is negative. It has to be negative, or else your answer might be off. Okay, and after that, make sure you draw out the two graphs in here, the two diagrams, one in the polar system and the other one in a complex plane in here, to double check your answer to see whether your 2 points end up in the same quadrant or no, okay, to double check whether your answer is right or wrong, okay? So number 2 is pretty easy, I think, compared to number 1 at least. And now let's talk about the third objective in here. How can you find a product and quotient of a complex number in polar form, right? So once you know a complex number already, you might want to make more complex numbers, just like the idea that once they give you the identity, you want to find more and more identities. That's why we have to establish like new identities. For complex number, once we have like 2 complex number, how can we make more complex number from there, right? Well, we can go back to the 4 operations that we always know. We can use addition to create like a sum vector, or like a sum of 2 complex number in there, or we can use subtraction, or we can have something like product and quotient in here also. But for the sake of this lecture, we will only focus on the product and quotient of complex numbers, okay? If you want, you can do more research by Google the sum and difference of a complex number if you want to. It will be like interesting if you want to read it. Okay, and what else do I want to say in here? Oh, okay. So given that we have like 2 complex number, I'm gonna call Z1 and Z2. Okay, and then Z1 would have R1 as radius, and then theta 1 is angle measurement. Z2 will have R2 as radius, and theta 2 as its angle measurement. Okay. First off in here, how can we find a product of the Z1 and Z2? So let me just put product in here, or like prod. For the radii, we're going to multiply them. because it's a product, so we're going to multiply them. But the special thing about this one is that the angle measurement in here, we're not going to multiply them anymore, because if you multiply like an angle with an angle, you're going to have like a huge, like massive measurement for the angle, and that's not the case in here. Okay, so for the product, we're going to multiply the radii in here, but we add the angle measurements. Okay, so make sure you don't multiply 2 times in here. For product, you multiply the radii and you add the angle. Okay, multiply the radii, add the angle. Don't multiply both of them. Okay, make sure you don't trip over this mistake, because I did it already in my exam and I screwed it up so bad. So I don't want you guys to like trip or like falling for the same mistake again. And then another topic that we interesting in is to find a quotient of it. So let me just put like quo in here for quotient. For quotient, it means like quotient, like fraction, for like division in here. For example, if I'm interested in finding z1 divided by z2 in here, for the radii, again, I'm going to do division. But for the angle in here, I'm going to do subtraction. Okay, so make sure you do division and subtraction in here. Don't do division twice. Okay. So again, for product, make sure you do multiplication for the radii and then you do addition for the angle. For the quotient, make sure you do division for the radii and subtraction for the angles, okay? Don't do any operation twice, because this is not the case in here, okay? So that's enough for the formula in here. Let's talk about like the practical problem in here. I'm going to give you guys like 2 vectors. The first one I'm going to call it Z, and the second one I'm going to call it W, so that you guys can get used to the name in here. So Z1 and Z2, they are just named, right? Like if I don't want it, I'm going to call like the first vector to be, or the first complex number to be A and the second complex number to be B. Whatever I want it to be, I'm going to call them differently, as long as they're different, and that works. They don't have to be Z1, Z2 all the time. They don't have to be Z and W all the time, okay? Make sure you don't get confused for like due to the name of them. They are just purely the names. They have nothing to do with like the inner algebra behind it, okay? So don't get confused by that. So to find the product of Z and W in here, I'm going to multiply the radii in here, and after that I'm going to add up the angles in here. And this one is my final answer. So then let me box it in, I don't know, yellow. Okay, so for the product, this is my final answer. As for the quotient in here, I'm going to divide the radii in here, and after that I'm going to subtract the angle measurement in here. And I do this example with a purpose to show you guys that it's not always just the bigger measurement, like minus the smaller angle measurement, okay? Like if I put Z on top in here, that means the angle for Z, it has to go first. Don't switch them, because if you switch them, it's going to mean differently. It's going to tell you that if you do like 270 minus 10 in here, it means that you do W divided by Z, okay? So let me put it down here so then you guys don't get confused over this one. So if I want, I can do W divided by Z, and in that case, I'm going to get 3 divided by 0.2 in here, and the angle in here. Okay. I'm running out of space, but technically the angle in here, let's do like one angle, for example. It equals to 270 minus 10 degrees, parentheses in here. And then I'm going to do like plus I psi, this is my S, and then 270 degrees minus 10 degrees, and then close the parentheses twice, okay? So make sure you don't get confused over like the idea of which one minus which one, okay? For addition, it doesn't matter, right? Because 2 plus 3 is the same thing as 3 plus 2, for example. But when it comes to subtraction, it's a huge difference, right? Because we all know that a negative angle is different from a positive angle because of the orientation. Positive measurement, it represents angles that goes counterclockwise, while negative angle represent angles that go clockwise. So that's a huge difference in there. Don't get confused between the two in here, okay? So again, there's a big difference between subtraction. Don't always go for a bigger number minus smallest number, okay? It's not the case in here, okay? The order in here, it matters a lot in here. And after that, I'm gonna have the answer as like 1/15 in here. So like, okay, so at this point, some of you guys might want to ask me, like in the exam, do I expect to have like to see decimal number or fraction in here? My answer is, if you have like a short, like a terminating decimal, for example, like 0.6, 0.3, that's short, write it as decimal. I don't mind. I would prefer fraction, however, because fraction looks like more lovely to me, to be honest. But if you have something ugly like 0.0333 like repeats like never stop, I would definitely have to go with fraction, because if you give me a decimal in there, that would be routing like issue. And then in the problem, I didn't ask you guys to route off anything, right? That's why in here I would refer fraction if the number is ugly. Okay. So in exam, if you have a dot ugly like decimal, make sure you represent it in the fraction form, or else just like confirm with me to clarify it during the exam. Okay. And in fact, you could have stopped in here if you want to, but then to be fancy, and then because you guys already know about the odd and even property in exam, I'm not gonna like super like satisfied with this answer right here. I would expect you guys to eliminate the negatives in here and in here. So if you guys remember, cosine is an even function. That's why the negative in here can be ignored. While sine here is an odd function, that's why the negative will be carried out, and the angle will be positive then. Okay, so this would be my final answer. Let me change it to green. So in the test, I would expect this answer rather than the other one, okay? So watch out for this. Be careful with this, okay? And as for your try problem, again, this one is your first complex number, and the other one is your second complex number. So all you have to do is to find the product of them, and then you have to find the quotient of them in this order, okay? If I ask you to do w divided by z, you would do it. But in here, I'm asking you to find z divided by w. That's why we have to stick with this order in here, okay? And in the exam, I'm going to tell you guys, like, what order I want you guys to do. I'm not going to be like, hey, find a quotient of these two numbers. No, I'm not going to be that vague, okay? So don't worry about those, okay? And the last part in here, for like the sake of like explanation, I always like pictures to make it more visual to like understand and remember. So I had like a little picture in here. This one for the product, and the other one is for the quotient. Okay, so what I'm saying is that at first you having a z factor, right, or like the z number in here. If you guys can see it in green, let me have it in green in here for z in here. Okay, so the angle in it is 10 degrees, so it's 10 degrees from the polar axis in here, and the magnitude of it is 0.2, right? That's why I wrote out in there. And after that, w, the magnitude of it is 3, so what I'm going to do is, like, I multiply the magnitude by 3 times, so 0.2 times 3, I'm going to end up having 0.6. But I still don't know where my angle is, right? So that's why I'm going to add up 270. Okay, let me put this one in blue first, so you know. This one in blue, that's why my 270 is in blue. I'm gonna adding up 270 from 10 degrees. That's why my blue angle is starting from the 10 degrees, like from here, not from the polar axis, okay? So, really quick recap in here. I start up with this vector in here. I start up with this angle in here from 10, and then after that, I use my 210 to piggyback on the 10 angle in here. So this one in here, the z, I start from the polar axis. For the second complex number, I start off from the first complex number, okay? So don't get confused by that. I guess let me just put it down here. So for the first number in green, I start from the polar axis. Let me just put pole. And then from the blue part, I start off from z, or like from 10 degrees. I didn't start from the polar axis. And the blue thing that I just wrote is z, not 2. If you guys like confused. Okay, and after that, I end up having 280 in here. And then extended like 0.6 away from the pole. And I have my product in here. Okay. With the similar logic, I'm going to have the quotient. So at the beginning, I start up with my z. This is my z in here by draw out my 10 degrees angle in there, and I extended like 0.2 unit away from the pole, and I have my z. After that, for the blue complex number, for like, because we have like subtraction in here, so instead of going counterclockwise, I'm gonna go clockwise in here. So I go back 270 degrees. That's why I had like negative 270 rather than like positive 270 in here. There's a big difference in here because this one is like I added and the other one I subtracted, right? So this one I'm gonna go like counterclockwise, and the other one I'm gonna go clockwise. Okay, And after that, I stop at negative 260 in here because 10 minus 270 equals to negative 260. And let me switch it to red in here. So that's why I had negative 260 in here. And then I did my math, and I do 0.2 divided by 3, and I end up having 1 divided by 15 as a magnitude. Okay? And that defines my point in here, z divided by w in here. Okay? If you want, you can draw the picture for this problem, like the side problem here, if you want to, just to test out like how you guys will understand like how to draw like the product or the quotient complex number in here in polar form. Okay, and I give you guys like 2 vectors in here. I would expect you guys to do one for the product again and the other one for the quotient. Okay, so please do them and let me know if that works. Okay, and not last topic of the day, we still have 2 more. All right, on the next topic in here, this one is really capitally important. We call it the De Moivre's theorem. What is so important about the De Moivre's theorem is that, just imagine from the last topic that we just learned, we know how to combine like 2 real numbers already, right? But what if the 2 numbers are the same, right? Like what if we have z and z, w and w, a and a are like b and b, right? What do we do? So in here, this one is like the psi problem that I want you guys to do before we get to the problem here. I mean, before we get to the theorem in here. So, for example, let me give you a z complex number in the form of r times cosine of theta plus I times psi of theta, okay? And my question is, how can you find z squared and how can you find z cubed, right? So, at this point, if you guys remember, x squared equals to x times x, right? So, to find z squared, we're going to do z times z. Okay, and each of the z in here we represented by this point here. For the radii, we're going to multiply them, and for the angle, we're going to add them. Okay, that's why I end up having this formula in here for z squared. Okay, for z cubed, let's remind ourselves x cubed. For x cubed in here, we could have started with x times x times x, but since we only know how to combine like 2 vectors from the last time, so let's do x times x squared or like x squared times x. Okay, it doesn't matter which way you want to go about it. So let's stick with z cubed equal to z squared times z in here. And again, we're going to multiply the radii in here. And by the way, z squared, we already had it from here. Okay, so we're going to use this one together with the formula in here for z. We combine the 2 together, and then we have r squared times r. And the angle in here, we will have 2 theta plus theta. Give me 1 second. My pen is out of battery for some weird reason. Okay, so what we're going to do about it is that we're going to combine z squared and z, the 2 complex numbers together, and then we're going to have z cubed. Okay? So we will end up having z cubed equal to r cubed times cosine of 3 theta plus I times psi of 3 theta. Let me test. Okay, my pen doesn't work anymore for some weird reason. I don't know why. Let me use my finger instead. Okay, sorry for this, you guys. It's gonna be ugly, but well. Okay, so let me box this thing really quick. So we end up having r cubed times cosine of 3 theta plus psi of 3 theta in here. And if you guys notice, if we have z squared in here, then we will have r squared and 2 theta. If we have z cubed in here, then we will have r cubed and 3 theta, right? So in general, if we have z to the n power, the radius would be r to the n. And then the angle in here would be n theta in general, okay? And n in here has to be a positive integer that's bigger or equal to 1, okay? So we cannot have like a negative power in here. And we cannot have like 0 in here, okay? And then from my experience, I give you guys some like heads up in here. So know that if z is in rectangular form, we have to convert z to polar form first to apply the De Moivre's theorem. So take away from this one is that make sure if you want to use a De Moivre's theorem in here, your point has to be in polar coordinate, okay? So you cannot have it in xy form, okay? If you were to have it in xy form, well, convert it to polar, okay? And then for this one in here, if you want, you can recall the unit circle, or else in the exam, I would expect you guys to show me how to use a reference angle in this case, not the unit circle, okay? And in here, the problem asks us to find z squared, and we have to write it in the form, in the polar form where we have a plus bi, okay? So this one is our z. The problem gives us z. How can we find z squared? Well, first of all, like right off the bat, this one is not the polar coordinate, right? And how do I know it? Because polar coordinate, you need to have r and you need to have theta. But in this form in here, it looks like x plus y I, right? So it's not the polar coordinate in here. So that's why, first of all, we have to convert it back to polar coordinate. And how we convert it back is that we learned from the last time already. So we would have to find r. Okay, so r in here equals to the square root of x squared plus y squared. So then we have r equals to the square root of -1 squared plus 1 squared equals to -2. That's why we have square root of 2 in front in here. And as for theta, because we know that cosine of theta equals to x divided by r, which is -1 divided by square root of 2. And then psi of theta equals to y divided by r, which is 1 divided by square root of 2. And then we draw the unit circle, and then we know that the x part is negative, the y part is positive. That's why it's end up being in question 2. And I told you guys that by the chart I made you guys remember, square root of 2 over 2 is the family of 45. So then it has to be 90 plus 45, and that's how we end up having 135. Okay, so this one is in the first example, in example 1. If you guys want to like check it out really quick before we move on, you guys can pause my video in here and then look at like example 1 if you guys confused. Okay, and after that we end up getting theta to be 135 degrees, or 3 pi over 4 in here. Okay, and after that, now that it's in the polar form already, we can use the De Moivre's formula in here. So z squared, we would have to do, like square up the radius in here. And as for the angle in here, we're gonna duplicate it. We're gonna like double it by 2 because we're looking for z squared, right? So what if I ask you to find like z cubed, right? Like how would you guys do it? Well, you guys will cube r, right? So it's gonna be like square root of 2 cubed. And as for the angle, like I'm gonna put like dot in here because I don't want to write the whole thing. But as for the angle, it's gonna look like 3 times 3 pi over 4, okay? And then we're gonna get like the answer after you like do your math in here. And then at this point here, you guys have to use your reference angle and the quadrantal angles in here if you guys remember what it is. So 3 pi over 2 in here, it is 270, right? So if you guys go ahead and draw the unit circle in here, 270 is like the angle right here. And if you guys recall like the coordinate of it, it looks like 0 and -1, right? Where 0 is the cosine part and then -1 is the psi part in here. That's why I have 0 in here and a -1 or like -I in here. And after that, I rewrite the 1, I multiply them in, and my final answer in here for z squared is -2i. Okay? And again, I would draw it out in like I would draw it out to make sense of it like visually. So the first picture I would have you guys draw is the complex number z, and the second picture I want you guys to draw is the picture of z squared. Okay, the first picture in here, the coordinate of this one, because it's in the form of x plus y I, so the coordinate of it will look like -1, 1. At the beginning, at the end in here, the coordinate of this one, it looks like x plus yi. Okay, let me write down x plus yi. But since there's no x part in here, so the coordinate of it would be 0. And then in front of I, we have -2. So the coordinate of it would be 0, -2. That's why in here we had 0, -2. And then on the first diagram, we have -1 and 1. Okay. So I would want you guys to do the same thing with this like z number in here for your try problem. The first diagram, I would want you guys to draw z. And the second diagram, you guys have to draw me z squared. Okay. And all the way next to the last topic of the day. Okay, so how can we find the complex roots? We learn how to find like the power of it, right? Like when we raise z to the power of like 1, 2, 3, or like whatever in there, we know how to do it in objective form ready. The other way around of it would be how to find the square root of it, the cube of it, the fourth of it, and so on, right? In general, how can we find a complex root of it? So in real numbers, okay, before we talk about complex number, I want to recall like a quick example about the real numbers in here. So in real numbers in here, we know, for example, let x squared equals to y in here. I hope you guys remember that this one is like the square root kept like form in here. So the graph of it will look like a sideways parabola-ish. Okay, let me put it in black again. So xy axis again, and then the graph of x squared plus y, equals to y will look like this. Okay, so if we were given that x equals 2, then we can compute y equals to 4, right? Because like if x equals to 2, then we will have something like 2 squared equals to 4, and that's how we get y equals to 4 from the fact that x equals to 2. However, if we were given y equals to 4 from the beginning, if we want to compute for the x value, we'll get two answers, right? We will have x equal to 2 and also x equal to negative 2. So that's like a big like hindrance in here. So make sure you guys notice the difference in here. If you start with x, you only have one y value, but if you start with y, you have two x values. Why is that so? Because for like a y value in here, for example, let me see. Oh, actually, I draw the wrong picture. This one is a picture of x equals to y squared. So the real picture, the real graph, it shouldn't be this. Sorry for this. Here, let me draw an diagram. This one, it will look like a parabola. I mess up a little bit in here. It's supposed to be a nicer parabola where like the vertex will touch on... Okay, whatever. You guys know what I mean. So this one in here is supposed to be like together, like the lowest point of the parabola is meant to be at the vertex or meant to be at the origin. Okay, so at a y value, say at like 4 in here, if you like project it sideways, this is your 2, and the other one, it will be your negative 2. That's why we have like two x values in there. Okay, so we're gonna have the same deal for a complex number in here. If I give you like okay, let's make it clear like this. Similarly in complex number, let me give you something like z squared equal to w. Let me underline it again. So let me give you z squared equal to w in here, and in here, if you want, you can treat the z in here like x and w in here like y. Okay, in the last example, we were given z, right? In the last example in here, it means objective 4 in here, if you guys want to double check on it. In the last example, we've given z, and then we have to find z squared, right? Which is like w in this case. So in 4, we were given z, and we have to find z squared. In the last objective of today, in objective 5 in here, we will be given z squared, and we have to find z. We have to do it the other way around, okay? And as you guys can guess, because we know the y value in here, and we have to find the x value in here, that would be two answers, okay? So, like just a sneak peek in here, we're gonna have to answer. We're gonna call z1 and z0 and z1 in here. And let's talk about a theorem in here. So in general, to find a complex root in here, assume that z to the n, or like z squared, z cubed, whatever you want to call it, like based on the problem in here, equals to w in here. Let w be a complex number of the form r times cos of theta naught plus I psi theta naught, okay? And n in here has to be bigger than 2, or at least it has to be equal to 2. So n cannot be 0, n cannot be 1, okay? W in here, it has to be different from 0 because it cannot be the origin, okay? So make sure it's not the origin. And n in here would be the distinct complex roots in here. For example, if you were to have like z squared in here, you have two complex root. We're going to call it z0 and z1. If you were to have z cubed, then we're going to have like 3 distinct root. We're going to call it z0, z1, z2. if you have z to the fourth, then we will have then we will have 4 distinct complex root. We're going to call it z0, z1, z2, z3. And if you have z to the 5th power, you're going to have 5 distinct complex root. We're going to call it z0, z1, z2, z3, and z4, okay? So that's just saying like for the k part, okay? So we start from z0, not z1, so careful with that, okay? And then the way that we're going to do it is that for the radius in here, we're going to take the end root in here, okay? For example, if you were to have z squared in here, then we're gonna take the square root. If we were given z cubed, then we're going to take the cube root. If we were given z to the 4th power, we're going to take the 4th root. And if we were given z to the 5th power, we're going to take the 5th root of the radius in here. And for the inside in here, first step in here, you have to locate your angle first. So the angle in here would be divided like equally into how many roots that you have in here. And in here you have n root. So we're going to divide by n. For square root in here, you're going to divide by 2. For cube root, we're going to divide by 3. For 4th root, we're going to divide by 4. For 5th root, you're going to divide by 5, and so on, okay? And to proceed to the next like root in here, we have to add it to like a circle, but then divided by n part like equally. We're gonna get more into it, like into details when we get to the example, okay? So don't worry if this formula doesn't make sense to you like right off the bat, but I want you guys to remember one thing, that first of all, for the roots in here, for the symbol of it, we start from z0, not z1, okay? So for example, for square root, you will be expecting z0 and z1, not z1 and z2, okay? And also for the square root in here, we're gonna take the square root of the radius, so make sure that's like the least that we can do in here. As for the angle, we'll get to know it more in example. And just like the Morse theorem in here, in order to apply like this rule of finding the complex root in here, you need your point to be in polar form, okay? So if you have the xy form or you have like the rectangular form in here, that's a big no-no. You cannot apply this rule in here. You cannot apply this formula in here to find the complex root right away. You have to convert it back to polar form, and then you can find a complex root after that, okay? So let's talk about an example in here. First, we having like the problem gives us something like w equals to negative 2i in here. And what is w, right? W in here is a complex number, and we have to find a complex square root. Okay, so the word square in here, it means that w equal to z squared. Okay, like just like to add on to it. And the form of w in here, because it's in the form of x plus yi in here. So in here, if you want, you can rewrite that 0 minus 2 I. Or if you want, you can also rewrite as 0 plus negative 2i to make it like explicit which one is x and which one is y in here. And because this one is in the xy form in here, it's definitely not the polar form already. So that's why we have to convert it back to polar form if we want to use a formula that we just learned. So how can we convert back to polar form? First of all, you have to know your radius, right? And the way that we figure out the radius is that we do square root of x squared plus y squared, which says that we're going to do square root of 0 squared plus negative 2 squared. And after that, you get 4. You take the square of it, you get 2. That's why the square root in here is 2. Okay? And as for the point here, the cosine value in here equals to x divided by r, meaning 0 divided by 2. So we get 0. And then the y part in here, it equals, and then the cosine value in here, it equals to y divided by r. It means that negative 2 divided by 2, that is negative 1. So we need to looking for something that have cosine equal to 0 and then sine equals to negative 2, right? And I told you guys, whenever you guys have the 0 in here, make sure you guys draw the picture of the 4 like quadrantal angle in here and label them. And I make like a typo in here. This one in here is not meant to be like a negative 2 in here. It's meant to be a negative 1. Why? Because we did negative 2 divided by 2 already. That's why we only have negative 1 in here. And if you want, you can like label on the point here. So the first one, it is 1, 0. And this one is 0, 1. And then next up in here, we have negative 1 and 0. And then the last point here is 0 and negative 1, right? So knowing that cosine is 0 and sine equals to negative 1 in here, if we put it in a point, it will look like 0, negative 1, right? And that in here is this point, 0 and negative 1. So our theta would be 270, which is 3 pi over 2. That's that circle. All right, and now that we have it in polar coordinate, so we can go ahead and apply this formula right here. Okay, how can we apply it? Because we want to find a complex square root, right? So first of all, we have to know the general formula for it. Okay, I call zk in here to be the general formula. So let me put the word general formula somewhere. I'm not going to write out the whole thing, but let me just put like gen in here and for like general formula for zk in here. In the test, you guys gonna be asked to give down the general formula first before you get to the two roots. Okay. So the general formula, what do we have to do in here, right? So because we're trying to find the square in here, so for the radius, we're gonna take the square of it, and for the angle in here, we're gonna divide it by 2. So 3 pi divided by 2, let me write in here. 3 pi divided by 2 divided by another 2. And this 2 in here is for the square root. So here, let me circle it in here for square root. That's why we divide by 2, okay? And if you lazy, if you want to punch it into the calculator, you're going to get the answer 3 pi over 4. If you want to think about it like logically, divided by 2, it means that you multiply by a half, right? So 3 pi times 1, you're going to get 3 pi, and then 2 times 2 on the bottom, you're going to get 4. That's why we have 3 pi over 4 in there, and we also have 3 pi over 4 in here also. For the k pi in here, at the beginning, it goes like 2k pi plus divided by 2, right? So let me put it in green in here. So at the beginning, it goes like 2, where should I write? So at the beginning, it goes like 2k pi divided by 2 for the square root again. And then we cancel out a 2. That's why we end up having k pi in here and in here. Okay. After that, what do? We're going to plug in values for k, just like before when we had like different, like many angles, like multiple angles in like 8.2, if I remember correctly. So the first solution in here, I'm going to call it Z0. And remember, we're going to have Z0 and Z1. We're not going to have Z1 and Z2, okay? So make sure you don't mix up the notation in here. For Z1, we're going to have, again, the radius in here. We're going to take the square of it, so it remains the same. Z1 in here, Z0 in here is when k equal to 0. So let me just put k equal to 0. So from here, everything would be the same. Nothing changed, right? For Z1 in here, k equals to 1. So coming from the general formula again, if k equals to 1 in here, from this part in here, we're going to get 3 pi divided by 4 plus pi. That's why we have 7 pi over 4. And again, 3 pi divided by 4 plus pi, we're going to get, again, 7 pi divided by 4, okay? And after that, I want you guys to draw like the reference angle by yourself this time and then define where 7 pi over 4 is. And if I'm not wrong, it should be on question 4. And on question 4, the cosine part would be positive and then the side part would be negative. That's why I have like the extra negative in here. Actually, let me just do it really quick in here too. So 7 pi over 4, it should be here. And because in the 45 families in here, so like the cosine and sine value by the chart that I made, you guys remember, is each equal to square root of 2 divided by 2, right? And now I just have to like make a judgment on the side part in here. So cosine of 7 pi over 4, it should be square root of 2 divided by 2. And the other one, side part, is also square root of 2 over 2. Since on the fourth quadrant, the cosine part will be positive and the side part will be negative. And we also have to account for the square root in front, so we multiply square root in here, and we will multiply the square root in here also. And then we end up having the answer as 1 minus I. Okay, that would be our final answer. And this one also. So in the end, we're going to have two complex square root in here, where Z0 equals to negative 1 plus I, and Z1 equals to 1 minus I. Okay, so to accompany your understanding to this problem here, I had two pictures in here. The first one, I draw my W. So again, the x part in here is 0 because it doesn't have any real part, and the y part in here is negative 2 because it's attached to the little I in here for the imaginary part. So the coordinate of it would be 0, negative 2, like a picture. That's the easy part, right? And the second part, the harder part, is when we have to draw out the two complex square root in here. the first complex square, z0, it has the coordinate of -1 and 1, because this point here, if you want to like write out, it is -1 and 1. The outer coordinate would be 1 comma -1. Okay, and then I should have used like another color. Let me backtrack and use another color to make it more clear. Okay, let me use, I don't know, yellow maybe. So from this point here, the coordinate of it would be -1 comma 1. And for this point here, the coordinate of it would be 1 comma -1. That's why I am having like the two coordinates to plot out. And if you notice, they are like right opposite to each other because they span like half of the plane in here. If you guys are interested in it, it's called, the word is called like spanning. And if you guys gonna take the linear algebra class, this word means a lot. So if you were to have like a cubic in here, those three vector are like those three complex number will span the space. They will be like equally like spaced out from each other. That's what it means also. And as for like a try problem in this example, I want you guys to try on this problem in here. And after that, I want you guys to draw like two diagrams in here. The first one is for W, and the other picture, the other diagram, I want you guys to draw the picture of Z0 and Z1, okay? So please let me know if that works, okay? Like, I know this is hard, and this is like the last section already, so thank you for staying with me, and please email me if you have like any problem. I wish you get good luck on the midterm and on the final as well, okay? So thank you for listening, and bye-bye. Take care.